Well, hello Cinemeric Nation, and welcome to Simply Cinemeric Live. I'm your host, Chris Pollock, and today we're going to look at a pretty unique function within the Cinemeric CNC that we call adaptive control and monitoring, or more affectionately, we refer to it as ACM. So adaptive control and monitoring is a unique feature that's going to monitor the spindle and the axis load while I'm physically running my part. Give me 1 second. I had my other computer's audio on. It's always something when you do these live events. Okay, so adaptive control and monitoring. So effectively what it's going to do is it's going to monitor my spindle and my feed and then optimize that feed profile as I'm engaging and disengaging into the material. Anywhere it sees my spindle load decreasing, it can increase the feed rate to maintain that constant spindle load. If I get into a heavy area and it sees the load spiking, it can then decrease it. So I will see improved cycle time as well as increased tool life, depending on how the product is being leveraged. Now, let's get right into it. There's no point in talking this whole time. So what we're going to do is we're going to transition over to my Cinemeric One control, and we're going to look at how I implement ACM on the product. Now, ACM on the Cinemeric CNC can be installed without any additional hardware. So it's going to run natively within our control, and what you're going to get is you're going to get a dashboard, which is your interface screen for the ACM function. Now, we've intentionally wanted to pay attention to how intensive this was on our operators for use. So the system itself is quite simple to utilize. When you power it up, it's automatically going to be turned on. And then from there, from an operator standpoint, all I need to do is check and select my my material hardness. So soft being more of your aluminum, your non-ferrous materials. Medium would be your typical steels and softer stainlesses. And then when I get into my more exotic materials, I can use a hard. Now in my demo, I'm going to be running this in aluminum. And then what I need to do is I need to just set the system into training mode. Now what ACM is going to do is it's going to first allow us to run one part to completion. And during that time, it's creating what we would consider a feed profile. So in the back end, it's monitoring every time that tool engages and disengages into the part, and it now knows where these conditions and anomalies can occur. So when I run the second one, it's now going to start to optimize, but it is dynamic. So if I get into an area that's harder or softer, it will then still appropriately adjust the feed. This is not a fixed scenario. But by having that feed profile, I can anticipate when the cutter is going to engage in the part. I'm not allowing the cutter to contact and then trying to react from it. So I turn on training, and then really I'm all set. So at this point, I could go over to my auto screen. I have a piece of stock already in there, and I can run my part. We're going to be cutting a little cog gear or spur gear that I've used for different applications. Thought it would be effectively a good use of this type of software. So when I come back to ACM, what I'm going to see is I see a couple different things on my dashboard. First, on the top, it's going to start detecting where the material is and what the cutting condition is. My center line there, kind of in purple, that's going to be the feed override. So in this case, I have my feed override at 100%, and it's not doing any adjustment because I'm in the training mode. And then on the bottom, I'm seeing what's happening to the spindle. So you can see areas where I've gone into load and out. The big spikes are where my spindle accelerates or decelerates. Now, at this point, I'm dropping in and I'm doing what we call an adaptive milling kind of tool path. So adaptive milling allows me to utilize a full length of cut. So in this scenario, I'm actually cutting 750 deep on my 1/2 inch end mill. So we're looking at approximately just under a 2 times D engagement. And then what I can do is I can achieve a much higher metal removal rate by reducing my radial engagement but increasing my feed rate. So adaptive milling, or also affectionately known as trochoidal milling, allows me higher feed rates than I typically would machine. So in this tool path that you're seeing here, I'm coming around, I'm running 140 inches per minute at approximately 7,000 RPM, a little less. Now, for this event, I had the privilege of being able to team up with Amugi, and Amugi provided me some specific tools for this exact application. So when we get to trochoidal milling or adaptive milling, there's a couple things that we can change from a strategy than I would normally be used to in a more traditional tool path. So for one, I'm going to be using a 5-flute tool, not a 3-flute cutter. So I'm using the Top Cut, which is a variable helix, variable geometry tool, but it is a 5-fluter. Now that's kind of unique in an aluminum scenario. A lot of us are typically used to 3-flute tools. The 5-flute tool is going to allow me a couple different things. It's going to allow me a larger core diameter at the center of it, so that's going to stabilize my cut. Now typically I would have a smaller core diameter with a larger cavity for the chip to flow in, but since we have that reduced radial engagement, because it's a trochoidal strategy, I don't have to actually worry about that smaller core diameter. So by increasing the core, the tool is much more stable. Also, by adding the extra flutes, I can not only run a much higher feed rate at the same or even a lower feed per tooth, but the tool is much more stable because I have more cutting edges engaged with the part at any given time. Now they said that this tool will effectively allow higher performance even on lighter machines or lower horsepower machines. My machine certainly is a smaller machine as far as its overall size, and I would have to say I'm seeing that claim. I mean, I am running probably feeds that I don't normally run on this machine with actually quite good performance on it. After we come through with the roughing tool, now we're going to switch over to a finish tool. Now in this case, I am using a 5-fluter as well. So this tool allows me to come down. Now I could have roughed and finished all with the same tool. This is the Tinox cut. But in my case, I did have to do that center pocket that you just saw me core out. That would be in the middle of the part. The Tinox themselves have a through spindle coolant port, so it does not allow me to do any ramping or any center cutting, obviously with that coolant port. So I wanted to use that tool for my finishing applications. And then later, we're going to get a chance to see a unique tool, brand new to the Amugi line. So new, they didn't even have any documentation yet on it, but they've come out with a new chamfer mill that I would have to say, after running it, is pretty impressive. Certainly chamfering, that's what we're switching over to now, has a tendency to be one of those operations where you compromise a lot of feed rate. Here, I'm able to run, I'm running, I believe, 40 inches a minute right now. Let's take a look, go back to our auto mode. 42 inches per minute at 7 grand, and hearing this tool run and seeing the finish, I think I can push this a lot harder. Just started playing with it, literally just got the tool last night, got it into the machine today, figured it'd be a good opportunity to fool around with it. Okay, so we're running our initial training or learning tool path. So shortly here, the system is going to stop, acknowledge that the program has ended, and then once I come in, I can now switch the system from training to operate. Now by putting it to operate, ACM is now showing me what it has detected during the cutting operations. So in this case, we can look, it's going to be opposite of the way the part's machined. So the last operation is going to be on the top of the list and then all the way down. So at the very bottom of the list is my facing operation. So here it's showing me my tool name and the programmed RPM of that tool. It's showing me some torque reference points, so it's kind of effectively showing me how much load or torque this tool path took to cut. And now what you'll see, which is interesting, is I have 3 separate operations for my 1/2-inch tool. Now typically, if I were to run exactly the same speed, spindle RPM, on all those operations, right? So I roughed out this outer profile right here. I then came and I did a spiral tool path, leaving the boss mill, and then I pocketed it. So if I ran all of that with just a single RPM, it would have grouped all of this into one operation. But a trick that you can use with ACM is I can change my spindle RPM really just slightly, even a couple RPM would be more than enough. and it'll break each of these into separate operations. So now I can adjust each operation independently of each other if I want to, or I can just let it run. And then it also detected my finishing pass. Now in here, I kept the RPM the whole time, so when it finished the boss and the profile and the bore, you'll see it grouped it as a single operation, and same thing for the chamfer. Now, if I select an operation, and I go to my operation state, I can now enable it by allowing it to use adaptive control, which you see it's turned on right there by default, or I can exclude it. So if I get to an operation, and maybe my finishing op would be an operation I may not want to allow it to adjust its feed rate to, I can jump in and override this state. But by default, if it thinks it can optimize it, it will automatically turn this on. As well, each operation, I can control what it's going to do. So I can control the maximum override of the feed rate. So I can let this tool or this operation go up to as high as 150% of my program feed rate. I can also control a threshold of the minimum feed before it's going to give me an alarm. My impact, which is now set to minimal, which I can adjust, well, that's a behavior of that feed profile, right? Since I know where the tool is going to come in or out of cut, I can then control how hard or soft it engages into the part. This is that mode right here, which I'm going to leave at minimal. So I come in, I make some tweaks if I feel necessary. If I don't, I can really go in, drop a new part in, and run my next piece. So let's take a look and see what the behavior of ACM is going to look like. So I'm just going to toss a new piece of stock in here. Man, those Amugi tools make a lot of chips. That's a good thing, right? All right. I'm just lining it up with the edge of my vise. Should be more than close enough. Okay. Now, I can certainly leave this screen on, or I can jump over to auto and I can let this all happen in the background. For me, I'm going to leave it on. So we're going to cycle start and we're going to run the part a second time. But now we have ACM in an operating mode, so it's now fully engaged and it's going to start to optimize. So what I'm seeing here, I'm going to see similar conditions, but I will notice where it felt like it can optimize the feed. So in the facing operation, because it's a pretty light load, it's not really doing too much here. It did accelerate it a little bit before we engaged in the part. So now it's going to come off. Here I'm seeing my spindle my spindle load as I'm engaging and disengaging. I'm going to see my ramp up here in a second. And now we're moving. So take a look what it was able to do. So where it saw that load varying, it's increasing and it's effectively running at this point the majority of the tool path was about 135% of its program feed. Now I'm getting into heavier cuts as I'm coming into each of those individual pockets. So whenever the tool comes off to re-engage, it's running the feed rate up at 150%, and then when I'm cutting into the material, it's dropping right down to my programmed feed, which would be that center line at 100. ACM is not here to tell you what feed rates that you intended this tool to cut at. What it's doing is it's saying, hey, when I was at the average condition, I want to be at 100% because that is the intent of the programmer. But where I see areas that my chip load is varying, I'm now going to increase or decrease. Now in this case, it didn't see any areas because the NX adaptive milling did such a nice job in the strategy. There weren't any areas where I was getting into too heavy a cut. But certainly based off of the material and kind of how the whole thing works, it is going to see areas where it can optimize its feed. Now we're going to do the spiral path. So here we're coming, whipping around, leaving the boss up. And in this case, you see when it goes into the void, it was increasing the feed, and now it's dipping down. Instead of shocking that tool, that's where it's kind of leading into the material a little bit. So I'm dropping below my program feed to engage into the part. And then as we come more into that consistent cut, you're going to see she normalizes out to my program feed rate, 100%. Now the circle pocket's interesting, right? Because now I'm machining the center bore at 100% program feed, but when it comes out to the second one, I have a lot less load because I've already cored the center. When I'm coring the center, I really almost have a 100% engagement on that tool. So it can optimize the outside, but it doesn't optimize the inside because it doesn't want to push your load beyond what you programmed. So I can see that all in that purple graph. Now we're going to run in, we're going to take that finish tool. Now when I'm looking at it in the auto mode, if there is an override, I'm going to see it in the programmed feed. So in this case, it was able to see, you can see it varying the feed based on the cut condition to kind of optimize that load. If I was to stay back at my dashboard, I'll see the same thing in my purple. So generally most users, most operators are going to let this kind of run in the background, really forget about it. If for any reason they do need to make a minor tweak, they certainly can. It's a pretty simple interface to learn. And here is our chamfer with the brand new Amugi tool. So even in this case, it saw that I can optimize it. So now we're running, let's see, 63 inches per minute. And that thing still sounds like butter. So I could certainly run that chamfering tool a lot faster. I'll give you the name in the comments once I find out a little more information about that tool. Okay, so that is ACM, that is how it behaves. Now, as I mentioned, ACM is dynamic. It's not fixed in space, right? So let's say I had parts where my material load was varying, right? Maybe I had voids or cavities or hard spots in the material. So if you watch, we're going to now run ACM a second time, and I'm not going to change the part. So effectively, I'm going to have no load to the spindle other than the nominal load of the spindle would normally need to take. So I'm just skimming across the top. So now you look, and since it's seeing the load significantly below that feed profile, it's maxing the feed rate out. Now obviously this is the most extreme case, but again showing this is fully dynamic. This is not locked specific to a given training. The training just gives us our baseline. So now we come down, we roll around, and you see the same thing here. Since it's realizes, so if I'm getting variances in my rough stock, let's say, I program for worse condition, but this will then speed it up if I have like maybe my smallest part as they're coming off the saw. Now as well, what we could do is if we wanted to, and I'm just going to stop it for now. If I wanted to exclude an operation, so let's say like that finishing op for argument's sake, it is really as simple as just being inside of ACM. You can go back to your operations with your operation button, pick the operation that I want to now exclude, and just pick exclude. Once you do that, you're going to see an X goes through it, so no longer is ACM going to affect that specific operation. So if we were to now run, and we can back out here. Let me just come over. And we'll search, find that tool. A lot of times when I search, I just do it to quick T equals, and I can drop down through my tools. So here I'm going to start at the 3/8 tool. So we can do a start search. I have the scanning mode turned on in our block search mode. So it's going to scan up to my start point, catch any modal commands that happen prior to that start. I say OK. And we'll cycle start. Got to change to the finishing tool. But now I'm running my program 50 inches per minute. Back from the ACM side, you see now it's not doing any adjustments on the feed rate with that operation excluded. So you do have full control here, depending on how you want to adjust it. Again, keep in mind under the operations, I can shut this off. Let's come off of it real quick. Under my operations, I can also control how dramatic I want to get. Now, as you run the part, you will also get a percentage for your time savings. So as I look through it, I can see each of the operations I let optimize, how much of a savings it gave. We should have probably looked at that before I ran the one fully in the air, because it is accruing, right? So as I run more parts, it's going to continue to log up the savings. But here it kind of gives you a nice high-level view to see effectively, is it working, and am I getting any kind of cycle time savings on my operation? Okay, so it looks like we had a few comments come in. Guillermo from Brazil says hello. Hello, Guillermo. He's a friend of mine, a colleague down in Brazil. I'm glad you were able to make it. So Vincent was asking, and John was asking, what Cinemeric control am I running? So this is our latest, we call the Cinemeric 1 control. So the Cinemeric 1 is the latest in a long series of controls we've had. This is what's replacing the 840D. So this is our kind of our high horsepower. This is the guy on the top of the heap. This is the PPU variant. So that means that the NCU of the control, the brain, is built into the back of this monitor. So very similar to a hardware profile of an 828. Additionally, we have NCU variants that would look just like a traditional 840, where you'd have the NCU in the back. And the performance is based on those. Okay. So yeah, John was saying he sees Cinemeric 1 on the screen, but it doesn't appear on an older control. Yeah, Cinemeric 1 that you see there is denoting that this is a Cinemeric 1. Can ACM be applied to turning operations also? Yes, it can. I will admit I haven't had a chance to try it, but we have had applications where guys were not only using it in turning, also using it in grinding applications, which is kind of interesting. I myself have had a chance to play around with it quite a bit with milling. I would say if you were going to ask me where I would look to leverage it, certainly I'm going to get the biggest advantages when I'm roughing. Right? When I'm roughing, when I have a lot of varying chip loads, maybe I'll have a lot of interrupted cuts, that's certainly where ACM can truly shine. If I'm doing a lot of finishing operations, a lot of times I want to make sure I control the feed, and by controlling it, any of that variance could affect the surface quality. But I will say on these parts, and I ran a couple for obviously testing purposes, even with the varying feed, I was able to get a beautiful surface finish. But I also do equate a lot of that to the Amugi tooling. For sure, when you run a high performance tool like that, it's amazing how much more we can push it and the quality you get. Okay. Is it available for the 840? Okay, so yes, you can get ACM in the 840 and in the later versions of the 828. So it is depending on your software versions. We have had a couple variations of ACM in the past. This is what we call Gen 2 or Generation 2. Now Gen 2 is our latest, and I would say it's the most easy to use. Certainly it is leveraging, I played around with the whole intelligence thing with the email blast, but it is leveraging almost like an AI concept, right? Gen 1, which we've had for a long time, which will not only run on Cinemeric controls, but can actually run on non-Cinemeric controls as well. So if you're running a non-Cinemeric platform and you're interested in looking at it, there is additional hardware required when we do a non-Cinemeric application. Right now, I believe Gen 1 typically is where we're going to leverage there. I think they are introducing Gen 2 for other controls, but certainly you're never going to see the full benefit that you would in a Cinemeric control. And I say that because I work for Machine Tool Systems, so it's my job to promote this baby. All right. Can I use the software for General Electric hole making standard? I would have to say, Thomas, I'm not sure. We could take that offline if you want to reach out to me. We could talk certainly further. Can ACM be used on other controls as well? Yes, as I mentioned, John was asking, can we run it? You can, but certainly you might be running the Gen 1 versus the Gen 2 variant. There is a lot more interaction from the operator in the Gen 1. Here we've really done a lot of work to try to make this as simple as you possibly can, but equally as powerful in the Gen 1 variation. We have a question. ACM has an option to control feed rate based on the minimum and maximum chip load. Is this similar? So that would be a static strategy, right? When you have an offline package like NX or a lot of third-party packages, they are looking at effectively where it sees the tool engage and disengage and optimizing, but at the end of the day, it has no idea what's truly happening at the spindle live. So what I would say is it's similar, but this can augment that. So just because you're using a strategy like that in like an offline programming environment doesn't mean you still can't get benefits from ACM. Remember, this is dynamic. So if anything is changing, part size is varying, material density is varying, maybe my tools on the shop floor is varying, it can compensate for that. All right. Kent was saying, thanks for choosing a Mugi. Absolutely. I tell you, I've run a Mugi taps in the past, never had a chance to play around with their end mills. I'm a convert. I think we'll be doing a lot more with the Mugi tooling moving forward. So I appreciate, obviously, the partnership with you as well, Kent. Are the hardness profiles customizable? Yes, they are. You can go in and tweak that. That would typically be done during the implementation of the software, but it's not very hard to do. There's a couple files that you could get in and modify if you need to. All right. Well, I think I got everybody. If I didn't, a lot of you guys probably know me. I certainly put my email address out there all the time in our different webinars and whatnot that's on the YouTube channel. So by all means, feel free to reach out, and I'd love to discuss further with you guys. If you have any questions on this product or any others, I'm certainly here available. With that being said, thank you for joining as well. Let's not forget, please like, share, and subscribe to the channel. By you guys liking this content and following us, it allows me to continue to do more. And I would have to admit, I do enjoy getting in front of you guys and working with some of these new tools and features. So with that being said, everybody have a great day, and we look forward to seeing you real soon. Bye-bye.